Hi, I'm Krishna, a PhD student at the chair of Communication Networks and the co-founders of one of the newest startups from the TU Dresden, Meshmerize. Today, in this video, I'd love to walk you through the technology behind Meshmerize and how we believe it's going to transform the way moving things connect to each other. These robots that you see right behind you, you might have seen them in some Facebook or LinkedIn posts. These are autonomous guided vehicles, AGVs, that transport shelves and other inventories within warehouses and factories, the backbone of the automated logistics industry of the future. One of the key challenges is to connect to them in a reliable way. Here's how it works today. In order to connect to these robots, there is a matrix of expensive access points installed on the ceiling. Each robot is connected to one access point. Connectivity is of course critical. If a robot loses connectivity, it stops. To prevent this from happening, they install more and more access points on the ceiling. After a certain amount, the access points start interfering with each other. Furthermore, the traditional approach of carefully engineered placement of access points don't work anymore, because with moving shelves, the environment is now dynamic, but the access points are static. Our research was focused on developing a resilient dynamic network for dynamic systems. Connectivity with Meshmerize looks like this. The robots are not only connected to the access points, but also cooperatively connected to each other using an overlay mesh network, specifically a multipath mesh network. The overlay mesh network serves as a reinforcement layer to the infrastructure network, making it more resilient to dynamically moving nodes, because in a mesh network, the robots become a part of the infrastructure, a dynamic network for a dynamic system. The redundant multipath routing of Meshmerize ensures that even if one or more links momentarily fail due to node dynamics, there is always an alternate path through which the data is routed to the node, thus enabling low latency and high reliability applications. That's enough theory. Let's see Meshmerize in action. This model car is equipped with a Raspberry Pi and a mesh access point on top of it. The Raspberry Pi is connected to a camera and to the motors of the car, allowing us to teleoperate the car through our mesh network. We constructed a mobile mesh testbed in our lab with 20 nodes to develop and evaluate Meshmerize for dynamic applications. Here's a simplified version with just 4 nodes for demonstration purposes. Access points running Meshmerize are spread across the big hall. One of the access points is connected to a PC with control software from which we can teleoperate the car using a simple Xbox controller. Both the video from the car and the control traffic to the car is transported through the mesh network. The mesh monitor software shows the status and corresponding traffic within the mesh network. We can witness the multipath routing of Meshmerize here with the cars connected to multiple access points at the same time. If you like what you learned today, or if you have any questions, or even better, if you think mesh networks or Meshmerize can solve a problem in your industry caused by dynamic systems, do let us know. Contact us at hello@meshmerize.net. Because after all, the tagline of our new startup is "You move, we connect." Thank you.